Hello everyone. Today we're going to talk about truss analysis with method of section. So before we learn about method of section, let's just review method of join. So what we learn in a method of join is whenever we have a truss, simple truss, we can analyze the internal force in the member. So the things that we are going to find is the internal force in AB, BC, and AC. Do you remember what was the step? The steps was, first of all, we need to find reaction. So the roller has one reaction, the hinge has two reactions. Then, after we found the reactions, the next step is to start from one joint that we know it's just only two unknown. It just only have two unknown. So for example, we can start from joint B or joint A and take the joint out, then draw free body diagram of the joint, then draw coordinate system X and Y, write equilibrium equation, sum of fx equals 0 and sum of fy equals 0. So we have only two unknown. They are internal force. So it's FBC and FBA. There are two unknown and two equations. So we can solve this system and find internal forces. So it's easy to find these forces. About the direction, it doesn't matter. We can assume both are in tension. Then later on, if we get negative, it means the assumption, the direction assumption was wrong. Okay, that's all for method of join. So in the method of join, we just analyze a joint, and if it's a large truss, it's very hard to analyze joint by joint. Sometimes we only need to know the internal force in the middle of the truss, but this method is very time consuming, but it's very easy because it's only two equations. Now we're going to introduce a new method that we call it method of section. So today's objective is to determine the internal force in the member with the method of section. For example, in this truss, you can see the floor beam, stringer, and deck. So we can transfer all these loads here, external loads. We also able to find support reaction. Instead of go joint by joint, we can, if we need only this member, we can use imaginary cut. That's why we call it method of section. Okay, let's see how it works. So for today's lecture, first we talk about application, then we introduce method of sections. That most of the time we use method of section because it's less time consuming and it's very easy to find a member anywhere we want. Then, as always, we solve some example to apply what we learn. Okay, let's see two application of trusses. You are familiar with line trusses used for construction, or electrical transmission towers, right? So if you want just analyze all the joint, it's very hard, especially in this electrical transmission tower. It's very hard to find all the joint internal force. So that's why we use method of section to determine these trusses, internal forces in truss. Let's see how we can approach this analysis. So first of all, here we have a truss. we can say, okay, we have only 2 reactions in the hinge and 1 reaction in the roller. So the first step is always analyze a reaction. Then if you want to use the method of joint, we need to analyze joint by joint to find BC, CG, or GF. But if we use method of fiction, we don't have to analyze all these joints. We use this cross-section area, AA, as an imaginary cut. So we know all the members in the truss, either they are in tension or they are in compression. So based on how we cut, we can draw tension or compression. Again, if you don't know if these truss members are in tension or compression, just you can assume they are in tension. If you get negative, it means it's in compression. So in this case, again, we use equilibrium equation. The only difference that we have in the method of section and method of joint is the number of equilibrium equation we use. In the method of joint, we only use sum of fx equals 0, sum of fy equals 0. But in the method of section, we also use sum of the moment about some point is 0. So we have 3 equations, right? How many unknown we can solve with these 3 equations? 3 unknown. Right? So let's see how it works. So remember the method of joint, we have only 2 equations and we can only solve up to 2 unknowns. In the method of section, we have 3 equations and we can solve up to 3 unknowns. Okay, let's see what is the step to analyze a truss with method of section. First, we need to find where is a good cut, where we can cut the truss and find out the internal force. So in this truss, if they ask to find the member internal force in the member BC, CG, and GF, where is a good cut? Usually the good cut is where we can cut the member we want to know, and the maximum number is 3. So in the next step, we have this cut. So we have all external forces, including external force, external reactions, dx, dy, fx, and all internal force. And 1000 Newton is an external force. So we just assume all of them are in tension. This one is in compression. But again, it's up to you how you want to analyze or assume the direction. So the first step is just find a good cut where you need to determine the force, internal force, like what is highlighted in the pictures, and where the total number of unknown doesn't exceed 3. Okay, so we have a good cut. What's the next step? The next step is determine which side we want to analyze. For example, I call this section 1, this section 2. Which side is easier to analyze? Again, we choose the one that is easier. Which one is easier to analyze? Correct. The number 1 is easier because we are not involved with finding reaction dx, dy, and ex. We have only 1 external force and 3 internal forces. So then the next step is to determine which section is easier to solve. Again, it doesn't matter which section you analyze, you get the same answer. But it's way easier to pick the one with lower number of external reaction and external loads. What is the next step is determine the support reaction if we need it. For example, if you pick this, the right side or number 2, we need to find the reactions first. All right, let's see what is the next step. After you draw free body diagram, if you know which direction, you can put all these forces, you can assume which direction. If not, just assume all of them are in tension, and then if you get negative, it means they are in compression. Okay, now you are ready to use equilibrium equation. So at this point, we pick the section we want to analyze, and then for this one, we can apply equilibrium equation. Sum of fx equals 0, sum of fy equals 0, and sum of the moment equals 0. Sum of fy and fx equals 0 is easy to find, but usually the tricky part is sum of the moment equals 0. Which point is a good point to get the moment about that you can get rid of a lot of internal or external loads? So this equation is the one that is most important. All right, let's see what is the next step. Applying equilibrium equation. All right, if, for example, in this one, in this side of truss, which point is a good one to get some of the moment? So we have here is A, B, G, C, and here it's imaginary, it's F. Which point is a good point? Which point is the point that we can get rid of a lot of unknowns? Yes, correct. Point C is a good one. Why it's a good one? Point C, because you can see FBC and FGC, both of them passing through point C, so we can get rid of that. The only forces that we have is 1000 and force in FGF. Okay, so if I get the moment, sum of the moment about C equals 0, the only forces that make moment are these forces that I'm going to highlight it. Okay, so it's the only force that make moment. So this is the only thing that if you learn how to get the moment about a specific point, makes solving the trusses very easy. Let's solve an example together and see how we can apply this method. So just recap, first step is if we need to find a reaction. The second step is find a good code that just require to find 3 unknowns, and also are the code is going through the member that we want to find internal force. What is the third step is to apply equilibrium equation, especially we need to be careful about which point we're getting the moment about. All right, let's solve an example together. Load as shown on the truss, and we're going to find the force in the member KJ, KD, and CD. So this is KJ. Oops. This is KJ. This is KD, and this is CD. Now you can tell which cut is a good cut for this truss. We want to find these highlighted members, right? So the good cut is the one that is going through these members. So we found out which cut is the best, okay? Then the next step is think about if we want to analyze the right part or left side. So this is something, it depends on us, which section is easier for us to analyze. Then determine the reactions and then apply equilibrium equation. So at this point, stop the video and find the reactions first. Then draw free body diagram for the left side and then see how you can apply equilibrium equation. All right, let's see the free body diagram. So we have 3 reactions, 2 in the hinge and 1 in a roller. Then we decide which part is a good cut, how we can find the reactions. If we write sum of fx equals 0, we can find ax because there is no external load in the x direction, ax is 0, right? For fy, ay plus gy should be equal to 20 plus 30 plus 40 Newton. So this is how we can find one of these ay or gy. But we have 2 unknown. Maybe a better solution is getting moment about g or ay. So go ahead and find out what is ay, and then we really don't need gy if we want to analyze the left side. So let's think about this way. So I want to analyze the left side. If I want to analyze the left side, I just need to find these 2 reactions. I don't need gy. It's okay if you find gy, but you really don't need it. Okay. So if we write sum of fx equals 0, ax is equals to 0. If you get the moment about g, remember, anytime you're finding the reaction, you shouldn't cut the truss. Anytime you find the reaction, you consider the whole truss with all external load. This is very tricky part. Remember, all the time for reaction, consider the whole truss. So I get the moment about mg, so it's ay multiply the distance. What is the distance? The distance is from A to G, which is 12 meters. It makes clockwise moment. If I assume clockwise is positive, so this one is positive. What else I have? I have 20 Newton. It's counterclockwise. Let's say it's 20 multiply the distance, which is 10 meters. Again, for 30 and 40 is the same things, multiply by lever arms, and you can find, let's say clockwise is positive. So this is how we can find ay. All right, at this point, I have ax, ay. Now the next step is to find internal force. Okay, think about how to draw free body diagram for the left part. Here is a free body diagram for left side. So this is free body diagram for left side of the truss. Right. So instead of the forces I had, I put internal force. And here is like, it's J and D. Okay, so I had my imaginary cut. I put all these internal forces. So these 3 are internal forces, 3 of them, that I'm going to find out what they are. The rest are all external loads, right? So what do you think? How we can solve this one? At this point, we have three unknown, and how many equations we have? We have three equations. Sum of fx equals 0, sum of fy equals 0, and sum of the moment about 0. Okay, it looks we have three unknowns. If I write sum of fx or sum of fy, I have a lot of unknown that I cannot solve. So let's start with sum of moment, or let's see, for sum of fy, I have this force, this force, this force, and the y component of this internal force. So I have only one unknown. So sum of fy, it works. If it doesn't, you start with sum of the moment. So let's start with sum of fy and see how we can solve this one. Either you can find the data, tangent inverse of data, because all the distances are given, so you can find the data, or other method and write sum of fy. All right, let's see what you get from sum of fy and how much is fkd. So if we write the sum of fy, you get the fkd is 8.05 kilonewton. All right, what's the next step? How about sum of fx? If I write sum of fx, the only x component I have is the x component of fkd, it's fcd and also fkj. So I write the sum of fx, and from here I can find fcd. Okay, so that's all for method of section. We're going to solve another example together to find out how we can solve this similar problem. Before we go over that problem, let's just have some concept quiz about where is the best cut or how we can solve this kind of problem. So the first concept quiz. We have this truss with all this external load, and we want to determine the member ED. Where's ED? It's right here. The highlighted one. So can you determine the force in member ED by making the cut at section AA? So this is our cut, okay? We want to find this member. So what is the best approach if we want to get the moment? Which point is a good point to get the moment if we cut this truss? So think about it for a minute, and I'm going to draw free body diagram for this one. I cut it from here, and I have all these forces. This force, this force, this force, this is ED, this is EB, and this one is AB. We also have one reaction here. that we already saw. Okay, so this is point E, and this is point B. Which point is a good one? It looks we can get the moment about E or B. If I get the moment about E, ED is passing through point E, so I cannot find it because it doesn't have any moment. There is another point, which is B. If I get the moment about B, all this force is passing through point B, so they cannot make moment. The only unknown I have is ED. I can solve for ED, right? So the best point is point B. All right, let's solve another concept quiz. It's similar problem. So if you know FED, now we find FED from previous section. Okay, now determine FEB. So we want to find FEB. Okay, so this is the question. How we can find FEB? By taking section BB and using some of the moment about E or other options. So if you look at this one, it's way easier if you use method of joint. I can take joint E. If I take joint E out and draw free body diagram, you can see this is point E, and I have EF, I have EB, and I have ED. Okay, I already know ED from previous concept quiz, so I want to find EB. If I run sum of Fy or Fx, I can find this one, right? So there is two unknown, two equations, sum of Fx equals 0 or sum of Fy equals 0, right? So in this case, I can use method of joint. It's interesting. I can use the combination of method of joint and method of section to solve this problem. So the correct answer is alternative B, taking section BB or analyzing joint E and using sum of Fx and sum of Fy equals 0. All right, it's great. Let's solve a group problem solving. So we're going to analyze this truss. All right, so we have 40 kilonewton, 50 kilonewton, 30 and 40 kilonewton external load. We have a roller here that it has only one reaction, Fy. We have a hinge here, so it has two reactions, Ax and Ay. So it asks for the internal force in ED. Where is ED? It's right here, EH and GH. So now you can tell me where is the best cut for this truss. Excellent. The best cut is from where we have all these internal loads. So here is the best cut. It's only 3 members. We have 3 equations we can solve, and also it's where we need this internal load. Then the next question is which part we would like to analyze the left side or right side? Yes, correct. If we analyze the left side, we have only one reaction at F, and that's it. Whereas if we analyze the other side, it's right side, we need to find AX, AY. We have a lot of external load. It makes it harder for us. So the first step, where to cut. The next step is which part you want to analyze. And the third step is apply equilibrium equation. All right. So stop the video and then draw free body diagram for left side, and then draw free body diagram for the left side and apply equilibrium equation. Then we're going to check the answer together. All right. So here, I just want to find Fy. Can I cut it and then find Fy? It looks easy if I do this, okay? If I use this part and just write the equilibrium equation, it looks, this one is equal to this one. But anytime you want to find the reactions, remember, you need to draw the free body diagram for the whole truss and apply all the external loads. It's not about finding reaction, it's not about internal load, it's about all external load. So anytime you are involved with support reaction, drawing free body diagram of entire truss. Okay, so if I draw for a free body diagram for the truss that you can see right here, how I can find Fy. So Fy is a question. Usually we use sum of Fx, sum of Fy, and sum of the moment to find out which one is the best. Very good. Sum of the moment about A. If I get the moment about A, I can get rid of AY, AX, also 50 kilonewton, also passing through point A. So it's the best point to get the moment. Go ahead, get the moment about A and find Fy. All right. Here is sum of the moment about A. So it's Fy, let's say, counterclockwise is positive, so it's Fy multiply the distance. What is the distance? Is 2 plus 2, which is 4. What's the direction? It makes clockwise moment, so it's negative. How about this 40 kilonewton? 40 kilonewton multiply the distance from A, which is 2 meters. As always, we use perpendicular distance. What's the direction? It makes counterclock moment. So if it's counterclock moment, based on the direction assumption, it's positive. Similarly, for 30 kilonewton, 30 kilonewton multiply the distance, which is 3 meters. Which direction it makes moment about A, which is counterclockwise, so it's positive. How about 40? 40 multiply the distance, which is 1.5, and make counterclockwise moment, so it's positive. How about this 50? This 50 passing through point A cannot make moment. So from here, we can find the reaction. So finding reactions are the first step. So this is the first step to find the reaction. What is next? Draw free body diagram of left side of the truss that we're going to analyze, and it's easier to analyze. Okay, let's go ahead and draw free body diagram for the left side with all internal load and external load. So this is all internal load, 40 kilonewton, and this reaction are external load. All right, think about equilibrium equation, which one works better? So we have sum of fx equals 0, sum of fy equals 0, and sum of the moment equals 0. And this is all unknown that we have. 3 equations, 2 unknown. Which one is the best? Yes, sum of the moment. About which point? So this point is point E, and this point is point D. So this is point E, this is point D. It's imaginary cost, remember? All right. Which point is a good point to get the moment? Correct. About point E. Because if you get the moment about E, all these forces going through E, and the only unknown is FED, you can solve for it. So this is the sum of the moment about, excuse me, it's sum of the moment about E and finding FED. What's the next step? Using sum of Fx or Fy to find the other unknown. For example, I start with sum of Fy and I can find FH. All right, go ahead and find the force with writing sum of Fy. Okay, so the only force in the y direction is the reaction 40 and y component of this one, correct? All right. What's the next? Can I use sum of the moment again instead of sum of Fx? Yes, I can use sum of the moment or use sum of Fx to find the other force that I haven't found. It's FED. If you want, you can write sum of Fx. Both is correct. So I write sum of the moment about H and find this point is point H. I wrote it E. Okay, so this is point H. All right, so it doesn't matter, you can use this one or sum of Fx equals 0. If you write sum of Fx equals 0, you also get the same answer. All right, let's see another concept quiz. Because the method of section is so important, we're going to focus on how to solve problem with method of section more than method of joint. Okay, so let's see another quiz. In this truss, it says two member GH, BG, it's this highlighted one, GB and BC to determine the force in them. Which section will you choose for analysis? Section A, left side or right side? Yes, correct. The correct answer is right side because it has fewer calculation. So this is the reaction, this is the reaction. The only force I have is 600 Newton. Whereas if I want to calculate everything in the left side, I need to find the reaction. First of all, I have 4 reactions, it's very hard to find. Then I need to analyze this one, whereas this part is easier to solve. Very good. Okay. Let's do the last quiz and then we're done for today. So when determining the force in the member HG, Let's see, where is Hg? It's right here. In the previous question, which one equation of equilibrium is the best one to use? Okay, this truss is given with one external load and 4 reaction. I want to find Hg very quickly. Which equation is the best? Sum of the moment about H, about G, about B, about C. Very good. Yes, the correct answer is C, sum of the moment about B. Remember, we have all these internal force. If we get the moment about point B, these forces cannot make any moment. The only force I need to find is this one, and it's easy to solve. All right, let's call it a day, and we have a quiz from method of section next Friday. All right, take care and have a good rest of the day.